Hello, this question is asking us to count how many different ways a group of things or a set of things can be chosen from a larger set. So what I mean by that is this is a counting problem, right? And there's three different main types of counting problems. It's either a combination or a permutation or a fundamental principle of counting. Now, combinations and permutations are different in that when you are selecting those things, everything is coming from one group of things. So like all of them are coming from this group, all of them are coming from another group, and then you're making that choice. Combination is where the order does not matter. Permutation is where once you make that choice, you're going to do something with those choices, as in like arrange them, place them, order them. Versus a fundamental principle of counting problem is when you have separate groups. You're picking one freshman out of group, a sophomore, a junior, and a senior. See, those are four different groups of things, and that's why it is not a combination or permutation. Permutation is when order matters. So when you look at these questions, you have to decide which type it is. Creamery Ice Cream Parlor has 27 different flavored scoops, and we'll put any group of 4 different flavors of ice cream into a bowl. How many different bowls of ice cream are there? And so it says grouping it, and so like when the ice cream is all mixed in there together, it doesn't matter the order, right? And so this is a combination problem, right? So I'm just going to put a big C here for combination. And for part B, it says you have 34 students. How many different ways can 5 students be sent to the flex space as a group? Okay, so 5 students are just going to the flex space at our school. They're not going to different flex spaces or anything like that, so that is another combination. So both of these are an example of a combination. So a big old C for that. So our notation for combinations then, we often will see something where there's an N, a big C, and then an R after it. The N is for the total amount of things you're choosing from. R is how many you are choosing. And so for part A here, you'd put a 27. We use little subscript notation there. 27 C, 4 different flavors. And so that'd be the notation that represents what this is. Now there's some factorials and there's a formula for this. But for us, we're just going to go right into using the calculator. So if you hit the math button on your calculator, and then you go over to where it says PRB for probability, you can see number 3 is NCR. And so that's what we're going to choose. Now the way my calculator has it set up, I have a little spot I can put the 27. If depending on your calculator, you have to learn your calculator. You might have to just type the 27 before you hit the math button. So you have to learn how to use your calculator, and you hit enter. And so that means that there are 17,550 different ice cream bowls. And then you do the same thing for the number of students. We have 34 students, and we are sending 5 to the flex space. So again, you might have to put 34 first into your calculator, but this calculator I don't. So I'm going to hit the math button, back over to probability, and you can see number 3 is NCR again. So I put 34 first, and then put a 5, and then you hit enter. And so that means that there are 278,256 ways that 5 different students could be sent to the flex space out of a class of 34. So these are these counting problems. Combination order doesn't matter. Permutation order does. Fundamental principle of counting means you have separate groups of things.